Okay, question number 15. The following statements concerning the location of an extreme value of a twice differentiable function f. That means it's a function, it has a first derivative and a second derivative, it's continuous, are all true. Which statement also includes the correct justification? Okay. The function has a maximum a. The function has a maximum x equals 5 because f prime of 5 equals 0. Okay, a maximum would look like this. Okay, yes, in this case, right, f prime would be equal to 0, but there's another option here where f prime of 5 could equal 0, and that's not a maximum, that's a minimum. So we know that a is incorrect, it's not the right one. Okay, now the function has a maximum x equals 5 because f prime of x is less than 0, so the derivative is negative for x is less than 5, and f prime of x is greater than 0, or the derivative is positive for x is greater than 5. So here's our little plot. Here's 1, 2, 3, 4, 5. And this is saying it's negative for x is less than 5 and positive for x is more than 5. Well, does that look like a maximum to you? No, that's clearly a minimum. So B is also incorrect. We go to C. The function has a minimum at x equals 3 because the tangent line at x equals 3 is horizontal. Okay, well, hey, yeah, there's a minimum, tangent line at x equals 3, yeah, that's horizontal, that works. But what about if instead at 1, 2, 3 I had something more like this? Well, hey, the tangent line's horizontal, same kind of reasoning as A, it could be a max or a min, so that's definitely incorrect. Alright, let's skip to E. The function has a minimum at x equals 3 because f double prime of 3 is less than 0. Okay, that's saying that the function is concave down. Concave down, remember, looks like this. Concave up is like a cup, concave down is like a frown, right? So f prime, so it's concave down. Well, if it's concave down at x equals 3, it can only be a maximum, right? So the only proper, so E is definitely incorrect. The only thing we have left is D. The function has a minimum at x equals 3, so let's see, 1, 2, 3, because f prime of x is less than 0 for x is less than 3. So derivative is negative, slope is negative for less than 3, and the derivative is positive, so slope is positive for x is greater than 3. So it's negative for x is less than 3 and positive for x is greater than 3. So does that look like a minimum? Yeah. And you know what? That's the only option, right? It couldn't be a maximum. That's the correct justification. In fact, that's how we would figure it out, right? We would say, okay, at 3, the slope is 0. If we find our derivative of our function, we found that it's 0 at 3. If we wanted to figure out if it's max or a min, we'd look over here. We'd say, oh, it's negative to the left and it's positive to the right. So that's a minimum. So that's definitely the correct answer is D. Alright, see ya on the next video.